Hello. Hello. Hello.
Good
Hello.
morning, sir.
Audible, no? Hello.
Sir, you are not audible.
Uh,
Hello. Huh?
Hello.
किशात
Audible.
ठेवा. Hello.
Uh,
Hello.
uh,
Yes, sir. Now you are
so
audible.
let us start now, right? Good
Start the
morning.
session for
Good morning,
10 minutes.
everybody. Today we are discussing about field instrument, very important part in the maintenance strategy, transmitter. And today we'll discuss HART transmitter basics. That will cover how it is installed, basic principle, configuration methods, and calibration tools. That entire part will cover. So in the slide you can see the actual picture of the transmitter, where you can see the this part is the sensor part, and above this is a electronics part, which, and here you can see the display, local display. And we'll see now. uh, if you see the 70s, late 70s, that time we were using only pneumatic transmitter, and this pneumatic transmitter was only giving a process value. One value means process value. Beyond that, pneumatic transmitter don't have anything diagnostic or no information about health of the transmitter, calibration related, maintenance related. So in the smart transmitter, or we call it the hard transmitter, uh, we'll get a lot of diagnostic informations, and how the benefits are there, that we are discussing. If you see the transmitter, I think in the second year we have discussed some basics, so we will go fast. So if you see that this is a transmitter here, which sends the process value to the controller here through AI card. Here your PID program or algorithm is executed, and then output is generated. And at the same time, it is displayed on the DCS workstations here, and output goes to analog output card, and then finally control wall. So this is the what a loop of the transmitter. If you see the industry transmitter ranges or tags, for your reference only, it is shown here various ranges. Serial number one, you can see the tag here, PI 1.1 synthesis gas area, where differential pressure across reactor R102. So this is for a differential pressure measurement. And what is the range? DP range, differential pressure range, is a 0 to 1 kg per centimeter square. So that is the measuring range, 0 to maximum 1. That is the differential pressure. And operating pressure range is 38. So differential is between 0 to 1, but its operating range is 38, right? Then you can see another transmitter here, which has a tag 01 DPR 360 DP across the heater. This is across the heater, and there also heating may be due to the steam. So differential is measured here, 0 to 1, 0 to 1, 38. Then DP across, again here, R reactor 201, but here range is 0 to 2 kg. So what I want to tell you here, this is where the transmitters are in the range of 0 to 1, 0 to maximum. You can see 0 to 1, 0 to 1 is a maximum. Then in the lower range also, 0 to 2500 millimeters of water column. These are low range transmitters, and that is the DP across. See, it's written another equipment 301, 302. So these are a lower range, but here you can see the transmitter with a higher temperature category, 900 degrees. This is the temperature at the reformer side. So when you, why I am showing this slide, the transmitter, when you have to specify, then you have to specify the differential pressure range, what for service, for what service it is used, then measuring range, then operating pressure of the line, and operating temperature also. So these are very very important parameters when transmitter has to be specified or installed for particular process, and that will give a best result. So this is what now I'm going first with the transmitter evolution. Earlier we have four wire transmitter. There the two wire for power and two wire for signal. So that was a 4 year, four wire were required. So two wires for the supply voltage and two wires for signal voltage. But in this system, signal loss is heavy due to the cable resistance and noise susceptibility. That was a disadvantage of the earlier transmitter, four wire. But this is what a four wire connection you can see here. This is the thermocouple, this is the controller side, and you see two wires for power. These two wires 24-volt power goes, and these are the signal wires. So signal wires increases here, so definitely line resistance affects the accuracy of the measuring parameter. uh, Now we have two wire transmitters, and two wire transmitters means what? Two wire transmitter draws a current for the power supply and the sensor input signal. So on the same wire, current is going in the loop. The control current lines has a high noise immunity, so simple twisted pair cables or wires can be used. Twisted means you always see the in the domestic side wires are twisted. So why it is twisted? Because uh, noise immunity uh, reduction. Why resistance does not affect why accuracy, as we are operating on the current measurement. Here we are operating on the current, not on voltage. So uh, resistance will not affect. Reduces cost of wiring because two wires you spare, and that is the benefits of two wire. And you see the two wire transmitter connections. This is a process side transmitter, and this is the control room side controller wiring. So these two wires, this and this way it is a loop. You can see this, and this is what looping, and power is you can see this is a power supply. So this way we get an advantage in the two wire system. Basically, this is a basic question always is ask, four wire to two wire. So two wire you will get a better results, no line loss, high noise immunity. uh, if you see the differential pressure, that you can see this is the orifice plate, and across the orifice plate we have a differential pressure for flow measurement. Mm. So there are various measurement techniques. We'll go fast because last year we have discussed basic sensors, but this is a strain gauge measurement. This is a high, low, and this way you get output here. Then capacitive sensor is a maximum use in the industry. It has a high reliability and accuracy also. So this capacitive sensor measurement, you can see these two. Uh, uh, I will show you the picture where you can see here two diaphragms here. One side is the HP line, the another is a LP line, which is coming from the orifice plate, and you see this diaphragm get high side get shifting toward the this is a reference diaphragm. This reference line. So this shifting, and because of shifting based on pressure, differential pressure, creates a differential capacitance, and this differential capacitance is measured through capacitance Wheaton's bridge, and you'll get a output here. So inductive also we have discussed. So this is what sensor assembly in the capacitive type. So you can see this as I explained you, pressure high, pressure low. These are isolating diaphragms. These are the diaphragms inside the. This is a cell body, and you see the pressure lead tube here, and here you have a micro capacitance silicon sensor here. As I told, sensor is there. So smart transmitter or hard transmitter, we can have functions available with your PC or laptop or hard communicator. Measuring point number, you will get a tag number. Measuring point description of the line, limits of measurements, measuring range, engineering units, measured values in milliampere or in percentage or in engineering unit, linear or square root extractor, damping. So many features you can check, because that information is available with a heart transmitter. And now you can see in industry we use one tool for for diagnostics or we can say configuration check, or we can say some part we can say calibration check. That tool is called a handheld communicator, HHC. I will show the picture. This is a powerful tool used in the by instrumentation engineering staff for maintenance of the transmitters. That is a handheld communicator, or it is called handheld terminal, or simply it is a hard communicator also. Easy to use menu oriented keyboard, functions versatility. There you can have a zero, span, damping, output signal. So many modes are there. Intrinsic shape this device is operational, means you can have optional printer outputs also, uh, up to range of 40 as to one rangeability. And you can see it has an indicator housing, everything is there. And here there are a lot of changes are happening in the communicator as far as the display electronics. You so displays are more powerful, colorful displays. Even nowadays a small device like ipad or can be used industrial grade ipad, we can say that type of devices are getting here. Earlier days communicator was like this, you see here. This was lcd displays, and these are the keypads use. And this is the connector which you can connect to the uh, transmitter backside housing. And in this picture, as I told again, this is a capacitor type sensor inside this. I'm just pointing it here only, in here. So this I have covered. This is a very important. How the transmitter, wherever always it is smart means heart transmitter field wiring. This is very important. You see here, this is your transmitter. This one is your transmitter, right? This is, and this is your communicator, as I told. And other instruments in the this transmitter in the line means in the field. So other instruments possibility that your recorder, power supply, controller, and indicators are there, and this way they are in the loop. You can see this plus minus here. Plus wire of this transmitter goes to this minus of this recorder, and then minus plus of this power supply, then minus of this goes to the controller. This is a single loop controller, it is shown in the picture. But nowadays we have dcs control, for example. Then this positive goes to the this indicator, digital indicator, if you have in the optional. And then here it is your communicator. Either you can connect in the normally it is connected not in the like this, but it is connected at a rear housing open. You have a terminal available here. You can see a communicator is written plus minus, so there you are connecting this communicator. But in this slide, you can see one resistance is shown. RL is equal to load resistance 250 ohm. So this is a very important, that in the hard communicator or in the hard protocol, minimum loop resistance when the transmitter is connected, hard transmitter is connected, has to be minimum 250. If it is a more, it's okay, but minimum 250 ohm is required, and therefore it is shown. Normally, when the transmitter is in the field, You have these loop devices always there, DCS controller, indicators, recorder, these are there, and the wires also there, and that has a resistance which is a more than 250. So no need to connect 250 ohm when you are connecting your communicator in the field. But when you are removing the transmitter, or transmitter is in your workshop, on table, workshop table, there these devices will not be there. So you require this resistance somewhere here in the loop. So 250 ohm is the standard for HART signal, that you keep in mind. So smart transmitter or HART transmitter function block, there are three or two important electronic circuitries. One is a sensor module, and another is a CPU module, electronics module. So in the CPU, which is there is a sensor first and then electronics. And here you have a CPU, memories, and other HART modems. Everything is there. And finally, these wires are coming out where at a terminal, and you are connecting this your HART communicator here. If you see there, and third, two important electronic cards, but third one is a there, that is a display board. You have seen in the display board, that is also electronic. So there are three separate replaceable cards in the transmitter. So if you see the smart or a hard transmitter function block diagram, as I explained, same thing is drawn here. Sensor in sensor unit, A to D converter, EEPROM is there in the sensor board, where sensor characteristics, sensor manufacturer range, as I told, differential pressure range, everything is or sensor calibrations. When you are replacing the transmitter with a new one, you can get that earlier transmitter information saved here, and you can straight away download to the new. So this EEPROM is very important, which carries the all sensor related detail, and sensor A to D converter is there. Then in the main electronic unit, you can see here microprocessor, CPU, EEPROM, and as I told, D to A converter is very important, and very important part is a communication model, modem, HART modem, because that is very important here for you get the HART signal where your diagnostics, analog and digital signals, everything is there. So this is what your 24 volt DC supply you are putting in the line, and this is a communicator, handheld communicator, and then it goes to the control system. This signal goes to the control system, plus minus like this. So this is the what block diagram. I think functional available with a local push button means in the transmitter, on local body of the transmitter, we can say there are two s- push buttons type or screws type, where you can set the full scale or zero span. So that you can do on the local. I will show you, but nobody is doing that because everybody is using communicator. So I'm skipping the transmitter basics now. This is what a sensor assembly. When you cut the transmitter, you will get this inside. I will go first. This is a process diaphragm outside. Second one is here. You can see here inside this. Uh, this is a sensing diaphragm center. This one main capillary tube. This another capillary tube which take a signal for electrical signal for microsensor, capacitance sensors, capacitance measurements. This is a glass portion inside, and this yellow is the oil, right? So these are the major parts. So here some animation is there shown. You can see here pressure applied, capacitance C1, C capillary tube C1 and C2, and how it is changes. You just see here. When the P1 is greater than P2, means high side is then what is happening? Your diaphragm has shifted here. You see earlier slide you just check. This is straight when P1 is equal to P2. This is a straight when P1 is equal to PT. So there is no differential. But here, what is happening? pH means P1 is greater than P2. So diaphragm has shifted like this. So like this, it is happening. So glass portion construction P1, P2. So this is a ceramic capacitor. Mm, mm. Even oil is there, huh? So this is a most trusted sensing technology in the world. No mechanical oscillation, no magnetic field. So therefore capacitor type transmitter or sensors are more popular in the industries. This internal part is shown, metal part, glass part. This is glass, ceramic. This is ceramic body, sensing diaphragm. This one, this is a sensing diaphragm, fill fluid, yellow, and metallized and capillary this. Hmm. Here you can see capacitance high and capacitance low. pH pressure high on the this side, pressure low on this side, capacitor high and capacitor low. Hmm. And the sensing diaphragm, see now change in the here. Differential pressure pH minus PL shifts the sensing diaphragm position, producing the change in capacitance. This is very important. You see the change is here. Pressure high, it is shifted to the this side, right? When PL is high, shifted to this side. So negative pressure here, you'll get a positive pressure. You must have seen the this animation also. I think I am not sure whether you are able to see. Mm. So differential pressure pH PL, gauge pressure dp is your pH minus atmosphere. Differential pressure means pH minus PL both sides, and gauge pressure means true only pressure. So that is with respect to the atmosphere. Absolute pressure means is the differential pressure pH minus 0 with vacuum. So no, this is absolute. There is no atmospheric pressure coming in this measurement. Absolute, exact. And in the level measurement, you can see dP is equal to pH minus PL. So pH minus PL is your level. That is this. That we have seen last year also. Gauge, as I told, true. Uh, this is the gauge true, gauge seal. So I'm just keeping that just to understand gauge and absolute. In the gauge pressure, you are having open to atmosphere, but in absolute, it is a vacuum. That's all. So here in this picture, sensor assembly is shown. I'm talking about a HART wired transmitter, and here you can see this is the what sensor is the capacitive sensor, which in the picture again it is shown, and in this electronics is there, and in this electronic isolator, signal isolation, sensory prom, temperature compensation sensor, all these are a major part is there, and the signal goes to the main circuit board, and this is the picture of main circuit board, which is this is the functional electronics, CPU, EEPROM, RAM, memory, local adjustment, as I told, push buttons, PROM memory, dead to A converter, HART modem, and output. Then finally, third part is a display controller, and you will get a display, which is a LCD display of the transmitter. So these are the major part of the HART transmitters. If you open it, as I told, display is shown here. This is a housing metal cover, and this is a main CPU standard board, and you can see the sensor is below this, and backside you can have wiring. And as I told, local push buttons are here on top. You see black color, you just remove this strip, just loose the screw. You can remove the strips, and there it is mentioned zero and spin using tool. This magnetic tool is there always, each manufacturer given, or normal screw also you push this. So this is what piezo-resistive sensor module, multi-variable sensor module. These are sensor modules, capacitive sensor modules. So capacitive electronics we are talking now. This is the what it is there inside this. So HART protocol we have discussed last year, but just I am refreshing you. Logic zero, HART means analog plus digital. Analog signal is a 4 to 20 milliampere. Digital is in the logic 0, logic 1. Logic 0 is the frequency 2200 hertz. Logic 1 is a 1200 hertz frequency. So this is what basic of this, and this we have discussed. So this is the transmitter we have discussed so far. This is a heart board, heart modem. That is what we are enjoying the features. And globally today, if you see the industry, 60 more than 60% transmitters are globally in the field are a heart transmitter. Even though foundation fibers, wireless, profibers, these transmitters are coming, they are having, we can say, share with the 10%, or I will say the 70% hard, remaining 30% FF, wireless, profibus, other transmitters are there, or normal analog transmitters or pneumatic transmitters if it is there. So 70% in the globally transmitter in the field are hard. So that much importance is there for this transmitter. And new, as I told, it is a, its transmitter basic remains same, only this field bus or profibus board is, this board is going out and this is coming inside. It's either it's a foundation field bus or profibus. You can see the logos of foundation field bus, profibus logo, and you can switch to the technology has switched to the field bus or profibus using this. So transmitter is installed here in the process line, up position, down position, sensor pressure, AI, damping. So these are related transmitter, damping factor characterization, range function, PID, and all this. So if you see here, output is a 4 to 20 milliamp coming out the transmitter. So these are the function available in the loop in the transmitter. So in the transmitter, one important part is that it's a display. In this slide, just I'm explaining you. The any the standard specifies any 43 is a global standard for communication or electrical signal. You can see the any 43 standards where the current value is associated with the saturated and failed. So transmitter has a two diagnostic message. One is a saturated, another is a fail. So how it is configured? But that is configured based on the current. This is your set range 4 to 20 milliampere, right? This is your what you are measuring the process value. But if the current is output side is more than 20, is 20 to 20.5, if it is there in the loop, transmitter is showing the diagnostic message, the saturated mode. That is also for lower side also. Below 4 up to 3.8 current shows means it will show, means it's a current related diagnostics. And if it is more than 20.5 or less than 3.8, it will show fail. Transmitter has a failed. So something is wrong with the power supply or something in the electronics of the transmitter. So output may be configured to go either 3.6 milliampere or 21 milliampere in case of sensor failure according to the NAMUR NE 43 standard. This is when a protocol was decided, the diagnostic is configured like this. It's the standard. In a most specific application, 21 milliampere is selected because it would indicate to the controller that the process variable is too high, causing the controller to reduce the process variable, preventing, for example, a tank from overflowing. At the same time, it would cause a process variable alarm if configured in the controller. So, moment transmitter value comes 21, controller will take action. There will be alarm, and as well as it will be uh, force the SEP output. So you see here, in this loop field, power supply, this is a controller, this is a communicator here, it is, and this is the transmitter here, and this is the loop. It is there. These are the non-standard loop instruments. Hmm. You see this transmitter, 420 milliampere loop. You just see a 250 ohm is introduced here, because to measure if there is a no much resistance, because there is a no DCS, is a PC only. So 250 ohm is added here. So if the transmitter is here, you have a multimeter here and you have communicator here. Suitable for gas and steam or liquid. This transmitter above open vessels, you can have this. So we have discussed, I think, last year. We are going ahead. Orifice plate, you can see here. Transmitter is shown here. This is the orifice plate. You can see this is the circular plate hole at the center, and there are various types of orifice plates: eccentric, centric, and this way flow rate is, differential pressure is created across this, and that is connected to differential pressure transmitter here. And this is based on Coriolis law here. Sorry, you see the principle. Flow rate is directly proportional to the differential square root of differential pressure. Now, when we are working with the transmitter, there are one method is called local adjustment. As I told, this tool is used to locally adjust zero span. Second is using communicator, hard communicator. This is a demo picture. Now communicator pictures from different manufacturers are different. Using laptop also, or PCs also. And this is the what communicator you nowadays looks like. But nowadays it is giving a colorful screen and more displays also. It is a 275. Now it is a 47 and above from immersion. So you get a better accessibility. Means access. I will come to that communicator later on. Huh? So this communication tool implements all the universal and common practice commands of the HART protocol revision 5. Hmm. Hmm. This I will skip, because now this is a I mean, in the communicator, this is what you get displays. You can see here address, calibration, data book, communicator details inside. Like this, you can click on this. You get when your generic configuration information, range, maintenance, specific, multi-drop, configuration, monitoring, password required. Yes. So if you are in the changing the range, then you just click on this and you can change the range like this. Tab button to access menus for different functions: information, monitoring, range, configuration, maintenance, multi-drop, and specification. Each function can be password protected individually. When button has a checkbox set, it means that the function can be only used after entering user password. So to avoid um, misuse, that's all. Password is required. The done button should be used as an exit command. It always return to the main menu. Suppose you are in the information menu, so it will display the tag number LD30. Descriptor is a 16 character. You can mention the line and detail of where it's the message. Here you can type, set the date and all. So tag 8 characters alphanumeric field for identification of the device, and remember to use graffiti writing for numbers and symbols. Descriptor 16 characters and messages if you like to add message. Then a date to assist with the maintenance or technical support. Additional information about the device can be found. Means here a very important part is you need not to use your hard copy. You'll get this information available in the sensor itself and CPU improm, and that you are reading on through communicator. So you can see the manufacturer details. Smart is the manufacturer, device type, device service. This is detail related to their product, software versions, everything is here. So no need to refer your documents. Means what happens, those who are earlier working there, then they shifted to another plant, or they shifted a job, then sometimes documents get misplaced. So earlier it was happening, but now it is not required, because it is no not required. Entire thing is available in the device itself. So when you are in the monitoring screen, device status, this function allows the user to monitor the device inputs and outputs, such as the pressure in an engineering unit, process variable in percentage, and temperature. So you can select here, for example, loop current in milliampere, PV, set value, tertiary value, and QV. So this button provides access to the device status information, right? And this button provides a way to change the variable codes definition, so the user can choose another variable to monitor. Means you have to some other variable you have to some, but not all device support this feature. This means you can see here, this is why I'm showing the communicator. When you are using, you will get this information like this. So what are the information? Our information, configuration, monitoring, controller, tree, maintenance. So in the information button, you will get a tag, descriptor, date, message, data. In the configuration, you can change the pressure range, and you need damping, transfer function, cutoff point, table point, displays. These are monitoring, controller indication. This also you can configure trim, pressure and current, maintenance model, serial number. You'll get this information. So this is what the information available inside the transmitter, and using a hard communicator you'll access that. So this I think we have discussed, but I will show you in this slide locally how it is zero span change. So as I told, there are two buttons, one for zero, another for span. So using this screwdriver, magnetic screwdriver, select and adjust, just push up and down. You'll get a simple rearrange to be applied. This is a manually done zero span. So you can see here, truly non-interactive zero and span. Set LRV 4 milliampere here. So using this screwdriver, you have set, because LRV, lower range, 4 milliampere. Now here set URB 20 milliampere. So this is the maximum. So you can set it in through this magnetic screwdriver like this. But as I told, the use of these tools are rarely done. So this is the my select two buttons here: increase value, decrease value, change option like this. Another tool is like a laptop, iPad, and you can connect it through modem. Here, this is the modem is required, HART modem with your PC or laptop, and connect to the transmitter, and you will get a better screen here because laptop you will get a more clarity information. So you can see here tag, date, description, boiler, message, ladder needed for access. So like this, details are available. Please. In the configuration screen, you can see the lower value, upper value in engineering unit, then units, damping, displays. So this is what used for configuration, calibration, monitoring, and diagnostics of the transmitter. Now, this communicator also gives the diagnostic messages to you. Suppose message is there on the communicator, parity error or overrun error or checksum error or framing error. The description is there. The line resistance is not according to the load curve, excessive noise or ripple, insufficient power supply, or interface damage, or your HHT means communicator battery is low. So it gives the your clarity to act on your maintenance, and that reduces your time downtime. When the message displays no response, means the line resistance is not according to the load curve, excessive noise or ripple, insufficient power supply, reverse polarity, even here something different. Polarity is different. Interface damage or not connected, address wrong, multi-drop or single. So these are the so accordingly you can act on this. Third message is line busy, other devices using the line. That is the description. Command not implemented. HHT and transmitter software versions are not compatible. HHT means your communicator is trying to carry out the LD30 specific command in another type of device, so he's busy. Next message is a transmitter busy. When we say transmitter busy, means transmitters carrying out an important task. For example, local adjustment parallel you are doing. So while communication, it will say the transmitter is busy. Means you are in the control room and somebody is in the field carrying out the local adjustment, which you are seeing using screw. That screwdriver, magnetic screwdriver I'm talking. Transmitter malfunction means sensor disconnected, sensor failure. Then message comes cold start, startup or reset due to power supply interruption. Output fix, output is constant current mode, transmitter is in multi-drop mode. The message you see output saturated means pressure outside set range, that we see either it is a 3.9 or 21 milliampere. PV out of limits. Here for this message pressure out of operational limits. Sensor module damaged or not connected. Invalid configuration. Set value out of limits means temperature out of operational limits. Temperature sensor damage. Low range value too high. The low range LRV was set above the value corresponding to 1.25 URL, like this messages are there. Low range value too low, upper range value too high. So these are the messages coming on the using either communicator or your workstation, maybe your laptop or PC. So why I'm showing it? So when you are working on this, you'll get this is a beneficial in the heart communicator features. So I'm going ahead little different when what is intrinsic SIP transmitter, because transmitters are in the critical plants, oil, gas, then refineries, even fertilizers and chemicals, power sectors, hazardous plants, high pressure plants. So there are standards for intrinsic SIP. So European standards, American standards, both are having same objective, different categorization. For example, in the American standard, which prominent organizations are ISA and CNELEC. So they specify zone 0, zone 1 and zone 2 for hazardous. However, in European FM and CSA, division 1 and division. So they in European standards, there are two only, division 1 and division 2. However, in American standard, they say zone 0, zone 1 and zone 2. So if you see the American standard zone 0, explosive air mixture continuously present or present for a long period in this plant, explosive gas and air mixture, then this area is called zone 0, and accordingly you have to select the zone 0 en- enclosure of the transmitters. Similarly, zone 1, explosive gas mixture is likely to occur in normal operation. Means sometimes any leakage is there in the line, and that is the zone 1 area. And zone 2 means explosive gas air mixture not likely to occur, and if it occurs, it will exist only for a short period. Means in your process, that particular gas is rarely used for some portion. It is not for major product or main product or uh, raw material or intermediate or final. So that is zone 2. So you can see here zone 0 and zone 1, this area is very very crucial, and there you have to need to take care of transmitter enclosures and electronics of that category. So for example, explosive for enclosures, electrical wiring or fittings are of that categories. Even in DCS side, you can see uh, even all cabling, junction boxes, termination, everything is expo category. You need to have approval from the manufacturers, certificate from the manufacturer, and all governing or compliance related organizations, authorities, government authorities, they check these certificates. And the equivalent to this European is a division 1, hazardous concentration of flammable gases or vapors or combustible dust or suspension continuously, intermittently or periodically present under normal operating conditions. So that is the division 1. So my point is that both are equivalent. But if you are purchasing any transmitter from European countries like Germany and all, then they provide this FMCS. If it is in the American side, for example, you are purchasing transmitter from Honeywell or Emerson, these are American companies, so they provide ISC. If you are taking transmitter from ABBs and Yokogawa, they provide this. Siemens, they provide this. Hmm. Then you can see EXIA, EXIB, explosion protection maintained with up to two components or other parts. Intrinsic appears may be connected in or associated see, these are, as I told, these related to that. Electronics are provided like galvanic isolation and system certification like this. So in short, what type of gases are coming in this group? Acetylene, hydrogen, ethylene, and propane. If you are in the process line, they are more inflammable. Mining industries, methane is there. So if you see here, mm, under the FMCS category, groups are there, acetylene. So these are the mentioning. I'm not going in detail. Just I'm telling you temperature, maximum temperature produced under fault condition at an ambient temperature. This. So I will skip this now because this is not up to this discussion. Our discussion is here hazardous area and safe area. So field is a hazardous area where, as I told, you require devices of that type, transmitter enclosure. Even here you can see the color of the communicators. When you are normal communicator, you can, this is a normal communicator, uh, and this is a hazardous communicator area. So same you cannot use here. Hard compatibility IS barriers, intrinsic safe barriers. So this is the control room and this is the hazard. So when plant is hazardous, you need con- communicator with a hazardous category. So intrinsic safe version of communicator IS is required when connected in the hazardous area. Hard compatible IS barrier is required to communicate. So always DCS barriers are there. So we, through barrier you can communicate in the control room. That is what it is mentioned. So intrinsic safe and flame proof, explosion proof, weather proof, high EMI, RFI immunity, Lloyd approach, like this. Some logos of that organization are there. FM, CE, CSA, EX, like this. You can have equivalent. Any you can take. So this is about a transmitter. Uh, this we have, I think, last year discussed, but manifolds and all. Just I'm going fast. This is about. Mm. So as I explained you, why 250 ohm loop resistance? Always this question is asked in the interviews. Most of the times, you can see here. Huh. I will come to this slide here. Huh. So this is the loop. 250 ohm loop resistance is required here. You can see the devices here: indicators, recorders, communicator, and transmitter. And this goes to the control wall, right? So 250 ohm loop resistance is required, but is often found as a shunt resistor on indicators, recorders, and controllers, or in the wire itself. Rarely does extra resistance need to be added. In this type of loop, no need to add extra resistance. That is what, because entire this device everywhere displays there. So always a display has a more than 100 ohm resistance. 250 ohm loop resistance is required, but is often found as a shunt resistor, as an indicator. That is what I have explained. So this is the logic for 250 ohm resistance. You see here, a minimum of 12 volt is required at the transmitter terminal. This way, the voltage 24 volt is consumed. A minimum of 250 ohm loop resistance is required for the digital communication to the function. So these two important part you have to you remember while working in the transmitter. So 0 to 1650 resistance ohm, while you can see here 250 ohm here above, this triangle gives the linearity here. So 0 to 250 ohm, so minimum resistance required. Supply voltage, suppose we have supply voltage 24 voltage, right? Oh, sorry. So in this slide, we have standard 24 volt DC supply, right? And this is the range here. So how it is calculated, you see here. For example, 1.5 kilometers of cable, 0.75 millimeters square at 22 ohms per kilometer gives a 66 ohm. Total, so here, total 570 ohm, maximum 21 milliampere and 12 volt minimum at terminals. So need 24 volt supply. So what is bifurcation you can see here? Normally cable resistance 66, record repeat is there in the loop 250 ohm, controller DCS control 250 ohm, and indicator repeat is there 4 ohm. So total force in the loop 570 ohm resistance is there and 24 volt supply. Ensure that power supply is sufficient for current to reach 21 milliampere. That is what you have to require. Then only you will get a diagnostics. So this is what we have seen. Mm, mm. This we will skip uh, because this is a related to pressure sensor. So 4 to 20 milliampere loop resistance. Read an existing 4 to 20 milliampere loop display. Read an existing 4 to 20 with the transmitter. You have transmitter display. So this is I will just summarize here. You can see here. Just I'm you just see 420 milliampere. You always have at least one receiver in a loop, such as a mechanical or digital readout indicator, chart recorder. So if anyone it is there though, so resistance is not required. You can have multiple receivers also, as long as there is enough DC voltage. I'm reading this. As long as there is enough DC voltage to supply the loop, you can insert many loops as you like. Many receivers have 250 ohms. Means each receiver has a 250 ohm resistance. So this is what it is. Mm, Not 250 ohm is not required when it is in the field. This is the statistics. 63% of instrument maintenance labor results, no action taken. Means I'm talking about the Boulder theory. When we don't have a HART communicator, that time any fault with the transmitter we have to remove from the line. So and then finally you come bring to the workshop and check it, then you find that's a simple choke or something, loose connection or air leakage like this. So 63% your maintenance budget cost was labor related. Waste of time is equal to waste of money. Means normally if you see the problems, runtime check 35%, no problem 28%. Actual problems calibration 20%, zero off 6%, plug line 6%, failure failed instrument 4%. These are the problems. Means only 4% problems come in this, 6% in this area, 6% this, and calibration is maximum 20%. But this was earlier was there, unnecessary we were putting our manpower and downtime is there, so that reduced due to the heart communicator. These are we have discussed it. So this is a very important equipment which I am showing. This is called calibrator, pressure calibrator and temperature calibrator. But this picture is a pressure calibrator. All transmitters in the pressure category you can calibrate. You can see the two different colors. As I told, this is a normal calibrator which you can use, but this is for hazardous area. EX, this one. Through this, you can uh, provide the pressure for checking pressure, as well as provide 24 volt DC, check input, check output. You can see there are many buttons helps, and you can pressure switch, I2P transmitter, everything you can check it here. There are termination here, and input also you can measure here, output also you can measure. So this is what is a very good instrument, and this is a pump here. this pump just push it and generate a pressure. Means in the workshop, in the lab, you can do calibration, or you can field also. You can take it safe area and do that calibration. So that is a portable calibrator. This is very important calibrating tool in the industry. Uh, Means communicator is there, but beyond communicator, don't we cannot give a input pressure or temperature. Here you can do that. So you can see in the how in the field using communicator, this calibrator you are testing, calibrating. You just connected the wire here, and you have connected input line here also, and you are pumping it. Just portable can. So this way you are connecting. You see electrical signal wires, and this is the actually pulse line pressure you are applying. So this is what about again you can have a, on the calibrator.
Hello, sir.
Hello.
Shall we
Yes.
continue tomorrow?
Yeah. Okay, I'm in the last slide. Okay, thank you. Thank you. Okay. Hello. Hello.
Yes, sir. Yes, sir. We
Okay,
will
I
meet
thank you.
tomorrow.
Thank
I
you.
will share
Okay.
your schedule.
So okay, thank you. Thank you, madam. Thank you.